Hello everyone, I'm Kamal Noori and here is Remote Sense Geoscience channel. Today I want to talk about electromagnetic waves and different environments. Please follow this session. This picture is showing land area and sea area and the source of energy as the sun and satellite or sensor. But different environments include five environments. One, atmosphere and cloud. Two, vegetation. Number three, soils and rocks. Number four, water and ice. Number five, urban area. The behavior of electromagnetic waves in different environments. Reflection, transmission, absorption, and scattering. When the electromagnetic arrive in different environments, occur for state. For example, reflection, transmission, absorption, and scattering. Note or important note. The reflected part is very important in remote sensing studies because the satellite sensor be able to receive and record this part. Just reflection part. Reflection part. Energy balance relationship. Important note. Initial energy equal reflected energy plus transmitted energy plus absorbed energy, and the sensor can receive reflected energy, not transmitted energy or not absorbed energy. Receiving and recording electromagnetic waves by satellite sensor. This slide is showing just reflection. Electromagnetic waves can be able with satellite sensor, not transmission, not absorption, just reflection waves. Electromagnetic waves reflected from the Earth's surface as soil, rock, vegetation, water, and urban area, and received by sensors in many different spectrum. For example, VNIR spectrum or SWIR spectrum or TIR spectrum. Receiving data and plotting spectral reflectance curve or SRC. This slide is showing spectral reflectance curve. In horizontal axis, we see VNIR, SWIR, and TIR. And on the vertical axis is reflectance in percent. What's spectral reflectance curve, SRC? This slide is showing spectral reflectance curve for soil, vegetation, and water. This is a graph that shows the intensity of reflection and different wavelengths. For example, soil, vegetation, and water in three spectrum of electromagnetic waves: visible, NIR or near infrared, and SWIR or short waves infrared. But this graph, a spectral reflectance curve of green vegetation. Horizontal axis is showing wavelengths in micrometers, and vertical axis is showing reflectance in percent. Negative peak in visible area, chlorophyll absorption, and in NIR or near infrared, reflectance due to spongy mesophyll, and negative or three negative uh, peaks in shortwave infrared, water absorption bond in 1.4 and 1.9 and 2.7. These negative peaks 1.4, 1.9 and 2.7 are water absorption bond in SWIR. This slide. A spectral reflectance curve of carbonate minerals. The plot shows that the major carbonate minerals, including dolomite, calcite, and magnesite, have significant absorption at around 2.35 micrometers, comparable to aster bond 8. Important note: for detection carbonate mineral, negative peak in 2.35 micrometers is very important, comparable to aster bond 8. This slide. A spectral reflectance curve in hematite. Minerals containing ferric iron Fe3+ in their lattices absorb light at 0.5 micrometers and 0.9 micrometers, which is comparable to aster bonds 1 and 3. Negative peaks in 0.5 and 0.9 for hematite minerals is very important. This slide is showing a spectral reflectance curve of magnetite. The lowest absorption for ferrous iron Fe2+ is around 0.65 micrometers, and between 0.9 and 1.0 micrometers, approximately aster bond number 3. For detection, magnetite. And this graph. A spectral reflectance curve of quartz. Quartz has strong absorption around 0.6 and 2.1 micrometers. Spectral reflectance curve of soil. Black soil S1, S2. Black soil has the reflectance, lowest reflectance or highest absorption. Spectral reflectance curve of water. Excuse me. Spectral reflectance curve of water. Turbid river water has the highest reflectance. Turbid river water 99 ng per liters. Clear lake water 10 milligram per liters. References for further study. Many thanks for your attention.